Hi guys, today we're going to talk about prime factorization. Yesterday, the lesson that I taught you was that prime numbers are numbers whose only factors are 1 and themselves, like the number 5. What times what equals 5? Only 1 and 5. So that's a prime number. Composite numbers are any of the other numbers that have more than just 2 factors. So a composite number is 12. 12 has 6, 2, and 2 and 3, and 2 and 2 and 3 are prime. Today we're going to talk about prime factorization. And what that means is that you can write every composite number as a product of prime factors. That's called prime factorization. So what I just did with this 12 here, it's called a factor tree. I broke it down and I found all of the prime numbers that make up 12. So I said, what times what equals 12? 6 and 2. What times what equals 6? 2 and 3. And when I can't go anymore, when I have prime numbers, I circle them. And then what I do is I'm going to make those a number sentence. 2 times 2. I like to put the ones that are the same together. 2 times 2 times 3. And when I multiply those together, I'm going to get 12. So 2 times 2 is 4 times 3 equals 12. So this is how I get 12 when I multiply its prime numbers together. So this is what we're going to practice today. And I'm going to use grid paper because I like to have lots and lots of space when I make my factor trees. You can use a piece of paper at home. You can use the yellow whiteboard I gave you. Whatever. It's not a whiteboard. It's a yellow board I gave you to help you out. Let's try the example in your book. Now this is on your book, page 81. And it says, Mr. Dempsey surveyed his class and found that his students have a total of 36 pets. Find the prime factorization of 36. So when it asks you to find the prime factorization, what it really wants is you to break down the number into a factor tree, which I'm going to show you how to do, and then write out all of the prime numbers in a number sentence multiplied together to equal that number. That's the prime factorization. So we find the prime factors by creating our tree. So find the primes by making a tree. And when it asks prime factorization, make them a number sentence like this. All right, let's practice. I can talk and talk and talk, but you really won't know what I'm trying to say until we practice. So let's do it. 36, it's once, and then again, this is page 81 in your book. 36, make 36 a prime factorization of 36. All right, so let's start by making our factor tree. Find the primes by making a tree. 36 at the top of the tree. Now, you're going to think of any two numbers that multiply together, any two factors of 36. It does not matter because you're going to get the same end result anyway, no matter which factors of 36 you pick. So you can pick 6 and 6. You can pick 9 and 3, or 9 and 4. You can pick 12 and 3. You can pick whatever ones you want to start out with. Do whatever you want. I'm going to pick 6 and 6 because I already have it written here. So two numbers that multiply together to be 36, two factors of 36 are 6 and 6. All right. Then you're going to decide, does my tree end here, or are there more branches on my tree? I can find out if there's more branches on my tree by deciding, is 6 a prime number, or is 6 a composite number? Does 6 have more factors than just 1 times 6? Yes, it totally does. I can get 6 by multiplying 2 times 3. Same with this 6. 2 times 3. So my tree has more branches. All right, now let's look. Is 2 a prime number? Can we multiply anything to get to 2 besides just 1 times 2? No, we can't. So 2 is prime. Let's circle it. How about 3? Can we multiply anything by anything to get 3 except for 1 times 3? Are there more factors than just 1 and 3? No, there's not. So 3 is prime. Let's go to this 6. We already decided 2 is prime and 3 is prime. Okay, so what we did here was we made a factor tree. And the factor tree is just a tool that we use to help us get to the bottom of what really are the prime numbers that make up 36. This is not the answer to the question. This is just what we use to help us get the answer. The question is asking us for the prime factorization of 36. How do we find that? Well, we just take the numbers that we circled, 2, 3, 2, 3, we put them together in a number multiplication number sentence. Looks like this. 2 times 3 times 2 times 3. And when we multiply all these prime numbers together, we're going to get 36. And if we don't get 36, then we must have made a mistake somewhere, so we should double check. 2 times 3 is 6. 2 times 3 is 6. 6 times 6 is 36. Does it check out? Yep. So this is the correct prime factorization of 36. Let's try something else. Let's try another one. Let's find the prime factorization, and do this with me. This is the second example on page 82. Let's find the prime factorization of 24. Remember, we're going to find the prime numbers by making our tree. At the top of the tree goes our product, the number that it wants us to find the prime factorization for. And you can pick in your book, if you're following along in your book, you'll see that they're kind of like telling you which factors to pick. 3 times something equals 24. And you don't have to pick that. If there's more than just that multiplies together, there's more factors of 24, you don't have to pick 3 times something. You can pick whatever you want. Let's do 6 times 4. Or 4 times 6. Same thing. Let's think. Does my tree end here? Or can I break these down into more prime numbers? Is 4 a prime number? Be careful. Lots of people stop at 4. I don't know what it is about 4, but lots of people stop at 4 and say, yep, it's prime, let me circle it. Think about that. Does 4 have more factors than just 1 times 4? Does something else multiply together to equal 4? Yes, 2 times 2, right? So we can't circle 4. It's not a prime number. It has more factors. 2 and 2. How about 6? What can we multiply together to get 6? We decided on the previous page. 2 times 3. Let's double check now. Does our tree end here? Are these all the prime numbers? 2 is prime. Yep, it doesn't have any more factors besides 1 times 2. And 3 is prime. It has no more factors besides just 1 times 3. So, remember, the tree is the tool that helps us find the primes. The prime factorization, which is the question we're asked to answer, is the number sentence that we create with our primes. So the prime factorization of 24 is 2 times 2 times 2 times 3. When we multiply that together, we should get 24. So we're coming up with a product of 24 using all of its prime numbers. Let's try it. 2 times 2 is 4. 2 times 3 is 6. 4 times 6 is 24. So it checks out. All right, let's do one more together. Actually, guys, and I tell my class this every year, I really love this lesson. I love making factor trees. It's a fun little project. I think it's a fun little math task to do, and I find that once my students get the hang of it, they kind of enjoy it too. All right, so this next one is find the prime factorization of 16. Okay, so we're going to put 16 at the top of our tree. Branch it out. What times what equals 16? Anything you can think of. You can say 4 and 4, or you can say 8 and 2. You know what you can't say? 1 and 16, because that's not going to help you. If I say 1 and 16, I'm going to be a part of this never-ending factor tree. So that's not going to help us at all. Let's not use 1 times the number ever in our factor trees unless that's the only factors that they have. Let's try that again. We don't want to say 1 times 16. Let's say 2 and 8. All right. Can anything times anything equal to besides 1 times 2? No. So that's prime. Let's circle it. We're already done with that. We're not going to branch that out anymore. How about this side of the tree? Can that have more branches? 8. What times what equals 8 besides 1 times 8? I know. 2 and 4. Okay, we already decided 2 is prime, so let's circle it. That branch is not going to have any more branches. How about 4? Remember when I told you about people making mistakes? Sometimes they'll say like, oh, 4, it's prime, and circle it. But think really hard. Is 4 a prime number? No, it's not a prime number. 2 times 2 equals 4. And we already know they're prime. So our number sentence is going to look like this. Our prime factorization for 16 is going to be 2 times 2 times 2 times 2 equals 16. Let's double check, make sure we're right. 2 times 2 is 4. 2 times 2 is 4. 4 times 4 equals 16. Checks out. We are correct. Are all of our numbers prime? Yep, 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 yep. Okay, guys, I believe in you. I think that you're going to do really well with this lesson. Remember, when it asks you for the prime factorization, it wants this number sentence. But the way to get there, the best way to get there is to use your factor trees. Go slow, little by little. It can be like a fun little activity for you to do. Today I want you to complete independent practice pages 83 and 13 through 15 on 84. Do the brain builders if you want an extra challenge for yourself. All right, come to live sessions if you need any help.